Hi everyone, welcome to the next video in this series where we will be uploading our application onto AWS Fargate. Have you ever wondered how to upload your application in a way that scales seamlessly? Well, stick around because Fargate is the perfect solution for this. As usual, I've left links in the description below to these articles, to these tutorials in written form. So if you feel like following this tutorial at your own pace using a written form factor, then links are down in the description for my Patreons. Now, there's a couple of things we need to do before we can actually start to set up AWS Fargate. The first one is, if you remember in the last video, we didn't fill in the credentials for the production configuration for our code to be able to access DynamoDB. And that was for good reason, because we didn't need it in that video. But today, since we're going to be uploading our application to production, then we do need to fill this in. So first things first, we need to make sure that you select a region in AWS, and whatever region you select, please insert that here. So I'm going to choose EU Central 1, so I need to change this here to Central 1, okay? And now we need to find the access key and the secret access key. So go to your IAM, so this is Identity and Access Management. Go into Users, and here, if you don't have a user, please create one quickly. And then when you create the user, inside, you will need to do a couple of things. You will need to add some permissions. So make sure you add a permission and select attach existing policies. And then when you're here, search for IAM full access altogether. Now, I won't find this because I've already attached the policy to my user. So if I go back here and I scroll these or open these, I can see IAM full access. This is the one that you need, right? So this user will have all access, so we don't need to kind of, configure access on a granular level. So then if I click onto security credentials, I will see here, you may not have a access key here, so you will need to create it. So go ahead and click on create access key, and this will create an access key. And this is the value that you need to copy into the access key configuration. And then if you show the secret access key, you need to copy that and paste it in here. And this is basically it. Now you can close this file, you can close everything, close this as well, and everything will be running once you deploy your application to AWS Fargate. So once that's done, the next thing that we need to do is to Dockerize our application. So inside of the root directory of your project, go ahead and create a file which is called Dockerfile with a capital D. So once you create the file, the first thing that we need to do is we need to tell Docker which base image do we want to use. So essentially a base image is something like, starting from a preset or a pre-built operating system with certain things already installed on it. So we're going to use the images which obviously have Node on it. And here I'm specifying also the architecture type. So AMD 64. You may not have to, don't need to do this. You may just, potentially, need to specify, for example, Node :14, which would mean that you're installing a Linux operating system with Node 14 installed on it. I need to specify that I want to use the AMD 64 architecture and then Node installed on this Linux version with this architecture, because I'm using a M1 Mac. And what that means is that my processor is a ARM processor, which is different to the AMD, which has a different architecture to the AMD 64 processors. And this means that by default, Docker would build an image for my processor. And when I upload that to the cloud, AWS Fargate currently doesn't support ARM processors, which means that it would crash. It wouldn't work. The Docker image would not work on AWS Fargate. So I need to specify that I need to pull Node from a image which runs on AMD 64 architecture. Next, we create a working directory and we just call it app. This is basically the same thing as creating a folder called app and then adding all of the files inside of this folder. Next, we create a environment variable called production. So this is to tell Node that we're on a production environment. And then we also need to specify AWS region environment variable. And this is essentially for AWS to, our application to know which region are we in and which region is our DynamoDB in. So I'm going to change this to EU Central 1, which is the region I've chosen for my project. So next we need to add everything that's going to be inside of the dist folder onto this working directory. And by the way, the dist folder is a folder that TypeScript will automatically create when we compile our project. Okay, so don't worry if you don't see this right now. Then we need to copy all of the package files, all of the package.json files also to this directory. So this would be package.json and package.lock. And then we need to run npm install on the container so that it installs all of our dependencies. And then additionally, we're going to be installing another library which has nothing to do with the project. And we're going to be installing it globally on the machine. And the library is called PM2. PM2 is essentially a process manager. So PM2 will be in charge of launching our application and making sure it's always up and running regardless if it crashes or maybe the process is killed by the operating system or what have you. Then we need to expose port 3001, which is the port that our application is listening to inside of the app.ts file here. And finally, we need to run a command to launch PM2, which is the library that we installed here. So the command is pm2-runtime, and we need to pass a couple of arguments to this command. So app.js, which is going to be the entry point to our application. So why are we not writing app.ts? Well, whenever we compile our application, as I said before, it's going to create a dist folder, and inside of this dist folder it's going to contain pure JavaScript files. So essentially TypeScript is nothing more than a language that compiles code to JavaScript, and we will be uploading the compiled files to the container. Okay, so that's why we need to write app.js. Then the rest of the arguments is just -i0, which basically tells PM2 to run as many processes running our application as it thinks is necessary. Right, so that's basically all of the extra things that we had to do inside of our project and the code and the source code itself. Everything else we will be doing needs to be done on the AWS platform. So first we need to create a repository that's going to contain the Docker images that we will be uploading here. Okay, so we need to go into the Elastic Container Service and click into repositories and create a new repository. Make sure it's private and give it a name which you prefer. So I'm going to call mine little link, and basically the rest of the options you can just leave default and just create this repository. Once this is created, you can see that AWS prompts you to view the push commands, which you can click, and this is very, very useful because AWS gives you all the commands you need to build the Docker container and to push it to your repository that you just created. So let's go ahead and copy each command one by one. So I'm inside of my project where I have all of the files. And what I'm going to do is I'm just going to run each command one by one. So this command has just logged my AWS client on my computer onto the repository since it's a private one. So that's done. Then we need to build our Docker image. Oh, and by the way, I forgot to compile the project. You can see that it cannot add dist because obviously if I lsal dist doesn't really exist. So before that, I need to run npm run tsc, which is the command that we use to compile the project from TypeScript to JavaScript. And then if I lsal, we can see that this folder exists. And now we can go back to actually building the Docker container or the Docker image. This may take a while. Okay, so once that's done, we can go ahead and copy the next command, which is just basically tagging the image with our repository URL, so that then we can push the image to our repository, okay? All right, so that's done. So now if we go into the repository, we should see that we have successfully uploaded our Docker image to the repository. Okay, so the next thing that we need to do is we need to start to set up Fargate. So the first thing that we need to do is we need to create a cluster. So we go here, we create a cluster, and we need to make sure it's a networking only cluster. Click next step and give it a name. Now, you want to make sure you don't select this option because AWS already provides us with a VPC. So a VPC is essentially a private network that AWS provides to us in each region for our applications to use, right? So we don't want to create another one. So we click create, and that was fairly straightforward. The next thing that we need to do is we need to create a task definition. So what is a task definition? So the AWS Fargate cluster is going to run a bunch of tasks. Tasks are synonymous to compute resources that will be running our application. So in order to tell what kind of compute resources we want to be running and what Docker images they should be hosting, we need to create a task definition, which, as the name suggests, it's the definition of the tasks, right? So let's go ahead and create a Fargate task definition. Here we're going to give it a name. Select the default execution role. Make sure this is set to Linux. Then here we're going to specify that we want to use the smallest available compute resources, okay? Now here we need to attach what container we want it to run, right? So we have to give it a name. So container-little link is what I'm going to use. And now we need to fetch the repository URL for the repository that we just created. So I'm just going to go back to the repositories, click this copy button for the URI, go back here and paste it in. And also we need to add :latest. So this will always make sure that we're grabbing the latest image that we push here, because if we push newer versions to this repository, then this previous one will be bumped down as to not being latest, and then the most recent one that we push will have a tag of latest. So we want to make sure that we're always grabbing the latest one. Here we're going to leave the values to default. And in this part, it's very important that you enter port mapping 3001 on TCP. This is because if you remember on our application on Express, we are listening to port 3001 on inbound traffic. The rest of the values you can just leave default. So we're going to click here, and essentially this is all we need to do for the task definition. So the next step is we need to go to the cluster, and here under services we need to create a new service. So a service is essentially what ties a task definition to a cluster. So we need to also make sure that it's a Fargate service. We're always going to be grabbing the latest version, and here we need to give it a name. So I'm always prepending LL, which stands in my case for little link, which is the name of the project that I gave it. And I'm always prepending it with what this thing is. So if it's a service or if it's a cluster or whatever it is, like that, it's going to be easier to identify for me later. Number of tasks, we want to keep it to a minimum, so just one. Leave the rest of the values as default. And then if we go to the next step, we need to set obviously our VPC and all of the subnets in our VPC. So in my case, I only have 3, but you may have more or less depending on what region you're in. And here it's very, very important that you create, under security groups, you create a new security group. This is very, very important. You need to give it a name. So I'm going to say allow TCP 3001. So a security group is essentially a rule that allows or filters the traffic that's allowed to go into your container, right? So since we are only going to be listening to traffic on port 3001 from our container, then we need to set this rule up. So I'm going to say custom TCP, and here at 3001, and then the source can be from anywhere. So we can listen to traffic from anywhere as long as it's on port 3001. So we can go ahead and save this. Next, load balancing. We need to set this up. So we need to make sure that we select application load balancer. And here you'll see that this input pops up. So I'm going to just set it to 30 for a second. I'll explain this in just a second, but make sure you also set it to somewhere around 30 or more. And now we see that it's asking us to select a load balancer, but we don't have any yet. So what we need to do is we need to click on this EC2 console to actually create one, and then we'll go back and select it. So you see, we have various types of application load balancers, and we need to create the application load balancer. So we need to give it a name. So I'll call it ALB for application load balancer -LL. It needs to be an internet-facing load balancer, and the IP address should be IPv4. Next, we want to select all of the subnets inside of our VPC. And then here it's very, very important that we create a new security group instead of just going on with the default one, right? So we create a new security group, and we're going to give it a name. And now we're going to say allow TCP 80. Okay, so it's going to be under our only VPC that we have. We don't have any more VPCs. So it's telling me I need to add a description. Okay, so now we need to define a inbound rule. So again, how are we going to be restricting traffic to the load balancer? So we're going to say custom TCP on port 80, and the source can be again from anywhere. Right. Why are we adding port 80 now instead of 3000 or 3001? Sorry. Well, the reason is now we're setting up security groups or rules for allowing or not allowing traffic to the load balancer, not the container. And since our load balancer is internet facing, so it's the piece of the architecture that's facing the internet, we need to expose default internet ports, and all of the websites in the world run on port 80 or 400, and I believe it's 43, which is the SSL instead. So HTTPS instead of HTTP. Port 80 is HTTP, and HTTPS is port, I believe, is 443. Okay, so for now we're just going to be exporting port 80, which is HTTP. And outbound rules is basically where can traffic go from once it's inside of the application load balancer. So it's basically just everywhere. Okay, so we're going to create this, and now we can close this tab because we can go back here, we can refresh this list, and we can select the security rule that we just created. By the way, I'm going to do this again because I want to first delete the default one and now select it. And since they have sometimes these cryptic names, I didn't see clearly which one was which. Okay, good. So next, it's asking us where are we going to be redirecting traffic to from the load balancer. So here we need to create a new target group. So again, the new tab, and we need to create a IP address based target group. We gotta give it a name. So TG for target group, LL for little link. And then the rest of the values can be default. So protocol 80, so this is HTTP, HTTP1. And then here, this is a very, very important part, health checks. So our load balancer is going to be evaluating the health of the tasks that we will be running in our cluster. And in order to do that, we need to provide with a path within our API that we can basically just send a simple response of a status code 200, which basically says that everything is fine, to this endpoint that we provide here. So in my case, it's basically just the root directory, because there we have the endpoint which just returns a OK. Okay, so make sure that you provide a endpoint that that basically does nothing other than return a status code of 200. Okay, so next, then we can click on next, and we can leave the rest of the values default, and basically that's it. So we can go ahead and close this tab, and then we can refresh this list, and we can select our target group. Okay, so let's create the load balancer. Now, once the load balancer is created, we can also close this and go back to actually creating our service, right? So we were here, this is where we left off. Now we can refresh this list and we have our application load balancer. Great. Next thing is we need to define the container to load balance, right? So which containers are going to be in the target group that we just defined in this load balancer. So here, this is the only option we have. So let's click add to load balance. And here, essentially, we need to select 80 HTTP for the production listening port. So what is the load balancing listening to? We only gave it one option, 80 HTTP. And where is it going to be directing traffic to? It's going to be directing traffic to the target group that we just created. And this is where the service is going to be adding the container that we previously added by providing the URI of the repository to this target group, to this load balancer, right? Okay, so that's pretty much it. We're not gonna play around with auto-scaling in this video yet. And basically we can go ahead and create the service. Great. Now, in a while, you should see that there's going to be tasks spinning up. Okay, we can see our first task is being provisioned. So this is great. So everything should be working, and we need to just give it a bit of time until it actually becomes active. All right, so we can see that our task is now up and running. So we can go inside and you see that we have a public IP. So we can just select it, go and access port 3001 and see if it's working. Excellent. We can see that we're responding with an OK. So let's go back. Now let's go to the application load balancer. So in order to do that, we need to access EC2. And inside of EC2, we go to load balancers. And here we're already selected with the only load balancer that we have. And here you can see that it's providing us with a DNS name. So this is the name or the URL that we can access the load balancer and have it redirect us to our application. So here you can see we have the same result, only this time we're accessing through port 8000. 80. That's why we didn't have to add this colon 3001, right? So it's redirecting traffic to the container, which is great. Now the last thing that we need to do is to just simply redirect our domain name to point to the load balancer. All right, so in order to configure your domain name to point to the load balancer, all we need to do is we need to go into Route 53, which is Amazon's product for managing domain names. And in here, we need to make sure we're inside of our domain name. So a little link in my case, we need to create a new record. And we can simply activate this alias button. So what this will do is it will simplify the process for us for redirecting traffic to. So here we can say we want to redirect little link without anything as a subdomain to a application load balancer with the region of EU Central 1, which is the one I'm using now. And here we can see our only application load balancer. And this is basically it, right? So this can take up to a couple of minutes to start to actually work in this link, but rest assured it will after some while. All right, guys, so I really hope that you enjoyed this video tutorial, and I hope you learned something how to set up AWS Fargate. It's not trivial when you first do it, but hopefully this tutorial gave you a step-by-step guide on how to do it successfully. So I really hope you learned something. Please hit the like button if you did, and please consider subscribing and becoming a patron if you want access to the written form of this tutorial where you can go at your own pace and implement everything step by step. So thanks again, and I'll see you in the next one.